Good morning, class. This morning we want to look at motor effect of electric current. Motor effect of electric current. The question is, what is actually motor effect? Remember, you were told that when you have a conductor carrying current, there's a magnetic field generated around that conductor. Now, if that conductor is now placed in a magnetic field, force will be acted upon, we act upon the conductor, making the conductor to move. The movement of that conductor is what we call motor effect. I'm trying to see. I have a conductor like this. This conductor is carrying current. There will be a magnetic field around the conductor. Now, magnetic field around this conductor. If I now place this conductor in a magnetic field where I have a magnet like this, and I place this conductor there will be interaction between the magnetic field around this conductor and the magnetic field of this magnet. That interaction will cause a force on that conductor, which will make the conductor to move. We call it motor effect. We'll be looking at force on a charge moving in a magnetic field. If a charge is placed in a magnetic field, the force that will act on that charge, and then force on a straight conductor carrying current. And then talk about direction of that force using Fleming's left-hand rule. And finally, applications of motor effect. Force on a charge moving in a magnetic field. If I have an electric charge, a charge can be positive, it can be negative. Protons are positive charge. Like what we have here is a positive charge, proton. Okay, you can also have electron, which is negative charge. You put it in a magnetic field. What happens to that charge? That charge is going to experience a force, which will make it go in a curved path. Now, and that force depends on three things: on the magnitude of the charge, on the magnetic flux of that magnet, and then the speed of the charge, and also the angle between the speed of the charge and the magnetic flux. Now, if that angle is zero, it means that the charge is parallel, it's moving parallel to the magnetic flux. In that case, the force will be zero. But if the angle is 90 degrees, the force will be maximum. A conductor, that is a force on a conductor carrying current in the magnetic field. That was the very first thing I explained. If you have a straight conductor carrying current and then you place it in a magnetic field, we say the interaction between the magnetic field around that conductor and the magnetic field of the magnet will cause a force to be exerted on that conductor, and the conductor is going to move, and we call it motor effect. Okay? This is a magnet, this is a conductor. Inside this magnetic field, this is a coil around this magnet. Now supplying current to this magnet. Now the magnet will move. Sorry, the coil, the conductor will move because of the force exerted on it. Fleming's left-hand rule. Fleming's left-hand rule, we use it to determine the motion or the force acting in a conductor carrying current placed in a magnetic field. Fleming's left-hand rule, if I have my thumb, I have my forefinger, and then I have my second finger placed at 90 degrees like this way. The thumb represents the direction of the force. The forefinger represents the direction of the magnetic field. While this second finger represents the direction of the current. With this, we'll be able to tell, okay, if I place it like this, if I have a magnet this way, the magnetic field is moving this way, and then I have a conductor in that magnet with currents going up. Now, you can ask me to determine the direction of the force on this conductor or the motion of the conductor itself. I just bring my hand like this, Fleming's left-hand rule. I look at, okay, I can see the field going this way, and I see the current. This is for field, this is for current. So I position if this is the field, I want the current to go the same direction as this my finger here. So this is the field, this is my finger. From what my eyes can see, it means that my force is going to go in this direction here. Now, this is the field. This is the current. The field, the current, then the force going in this direction. Lastly, applications of motor effect. We have the moving coil meter, which we call the ammeter, the voltmeter, and the galvanometer. We also have the electric motor, the loudspeaker, and the magnetic relay. Now, one of the most important in all these ones I've mentioned is the electric motor. In subsequent lessons, we're looking at the electric motor and how it affects us. Thank you very much.